The chain of custody process model entails 4 phases: acquisition, analysis, report, and destruction. And it also involves 3 predominant processes: evidence register, evidence access, and evidence destruction. The actual evidence is actually stored separately on a different secured evidence database, and during this to interact with the evidence itself, we have some evidence services that have been defined. So coming back to the chain of custody phases, during the acquisition phase, this is where the chain of custody actually gets instantiated. It begins at the evidence acquisition phase, and once evidence is collected, the process of creating the evidence must be instantiated in the chain of custody. So during the second phase, which is analysis, this invokes the process of analyzing the evidence access by the corresponding participant. During the reporting phase, it invokes the process of reporting the evidence access by the corresponding participant. And lastly, during the destruction phase, in case the destruction is requested, invoking the method destruction of evidence will be needed. So, as I mentioned before, to interact with the evidence, you have some evidence services that have been defined. For instance, you have a create evidence. So the person responsible for acquiring the evidence signs the record and creates a record in the blockchain network. The obtain evidence service, this is where registration of all the participants requesting access to the evidence. Then you have invalidate evidence. Necessary the who, when, how, and why the destruction of a particular evidence was authorized must be recorded. And to transfer ownership of evidence, you have a transfer evidence service necessary to delegate the management of the evidence to participants that they're transferring that to. And then show the register evidence pretty much reports on all the entries in the log about a particular piece of evidence. You also have the different roles that have been defined that will have different capabilities, functionalities when dealing with the evidence. You have the evidence creator. They create a record in the chain of custody, assign an owner, manage participation, participants' access to the evidence, and notify of any exceptions. You have the evidence owner, access to security officer for the credential generation of the participants to allow them to access the corresponding evidence. You have a master participant, which is responsible for the deployment of the smart contract and maintenance of the participants in the complete process. And then you have other authorized participants. They could be investigators, researchers, examiners, or law enforcement that need to interact with the evidence. So some of the design principles for the technical solutions are firstly, a smart contract that implements the logic of a secure, simple, and standard process of chain of custody. The data related to the chain of custody are only accessed through the smart contract. Deployment of the smart contract in one or more consortium of blockchain. Permissive technologies with zero-knowledge proof consensus support. Custody of the evidence in a separated way from the evidence in the chain of custody record. Robust identity management and authentication method. The use of safe, reliable, durable, and low-cost warehousing. Electronic evidence format following an open standard. And periodic accreditation of external security audits. So these are some guiding principles that are used for the technical solution. So based on the guiding principles, technical solutions were developed and ended up with a distributed architecture. So the main elements in there, you have a browser. So the participants connect through a browser to the chain of custody application. And as a consequence, to her or his specific identity node. And the connection is performed via HTTPS connection, depending on a device, be it a mobile or workstation. And the application sends the browser the necessary JavaScript to interact with a blockchain network. So you also have a wallet. It is needed for the chain of custody communication process among the chain of custody participants and identity nodes. And for the Ethereum network, which is what was being used, Quorum version of things, Ethereum, it is common to use a combination of Web3j and MetaMask. For communication with the blockchain network, the entity node, depending on the underlying technology, will have an interface for interaction with the outside. So in our case, for Ethereum network, in particular the case of Quorum, it's an XML RPC with Hyperledger. It is an API-based REST version of things. So for communication of safe storage events, the source store, secure store, must have the ability to generate events against the node to report access to the stored evidence, and proposed how to use this by implementing function as a service, such as AWS Lambda, which reads the log of evidence generated by the storage system and generates an audit log directly in the smart contract. So because you'll be having offline, you're uploading evidence during the acquisition, the process, chain of custody process model. So offline upload of evidence, this is formalize the protocol for sending the evidence to the offline provider for uploading of massive data migration to avoid that problems with cost and scalability as well, because some of the evidence could be massive in size, especially when you're talking about hard drive images and whatnot. So to facilitate interaction within the gateway safe storage, application must manage uploading and downloading of evidence from the client's device. Access will be made with service accounts with granular permissions to the evidence managed from the identity management module. So in the case of downloading, a secure URI must be generated for downloading from the client. So as proof of concept for the smart contracts and Ethereum for the chain of custody process, the prototype developed is as follows. So it highlighted the different interactions between the various elements. So for instance, in interaction A, interaction between client application and distributed application. So the client, through the browser or any other compatible browser provided by MetaMask, accesses the distributed application by an HTTP communication. And the web server does not interact with the smart contract or the blockchain network. In order to achieve this, the browser downloads some JavaScript code from the node server, and this includes the interface and style sheets. For interaction B between the client application and smart contract, the application client interacts directly with the smart contract deployed on the network node. The client browser can do this through Web3, JavaScript library, and the MetaMask extension. Interaction C between the distributed application and the safe gateway. So the safe storage is organized as a server that provides different REST services. So in the case of concept, it provides a service for uploading and downloading information. The specific interaction between the application and the gateway is to adjust the upload or download parameters so that the browser can manage the information directly from the safe gateway. For interaction D between the safe gateway and the safe storage. So the safe gateway is in charge of collecting or sending information from or to the safe storage, and through this option, the file requested to be downloaded or sent by the client is collected by the gateway. With the corresponding credentials, this is in charge of remotely storing files. So this fact allows a control, an abstraction layer of the safe storage without the client knowing the storage details of or credentials. And as suggested further work, the gateway could perform additional controls on the information managed, for example, recalculating the fingerprints of evidence or encrypting of data, etc. For interaction E between the client application and safe storage, so the volume of electronic evidence could be in gigabytes or terabytes, petabytes. So in these cases, it is reasonable for the client to interact directly with the store with his or her specific native credentials and tools. For example, Google's tool or the offline data migration available from most cloud storage providers such as Amazon, AWS. And for interaction F, the development environment and the smart contract. So the Remix environment is ideal for the development and debugging tasks of the smart contract. An Ethereum virtual machine can be used as well, accessed with client via Web3 or MetaMask to interconnect with Ethereum. It has a multitude of options to be able to develop, compile, debug, and test the smart contract. And interaction G, compilation and deployment, and smart contract. So for the compilation and deployment of the smart contract, the Truffle suite was actually used, and that allows the deployment of Ethereum-based blockchain network. The application deployment is also used to compile and migrate the contract to corresponding network.